Hello, everybody. Who has heard about locomotors before? Okay. Still a lot of education to do. That's typical. But that's great. So I'm going to start the timer, making sure that I'm not running over time. So locomotors, let's see, is a company that design, build, and sells vehicles. You have Volvo, Saab, Daimler, Volkswagen. They are designing, building, and selling vehicles. We're doing the same. The slight difference between those incumbent players, large OEMs, and us is that we were born later. We were born in the digital age. And we're using digital age tools to design, build, and sell vehicles. For the development, we're using a collaborative development process that we call co-creation. It is hosted on our platform, locomotors.com. Everybody is free to come and join and start participating in the co-creation of our vehicles. The community today is over 53,000 people. They are designers, engineers, enthusiasts, people that are supplying different components and want to get those systems out. And we embed them in the development process. 53,000 people from 130 different countries. When they come to the site and share an ID, share a CAD file, share a line of code, all those different elements are protected by the Creative Commons license, meaning that they remain the owner of what they bring to the community. And when we take those ideas, those different elements to production and to market, and there is a royalty that is given back to the community. Once the vehicles are developed, we bring them in production in small-scale production units that we call microfactories. We embed them in the local economies where the vehicles are going to be used. And locally, we design, build, and sell. We have a lab inside the microfactory that we use to develop new vehicles. We give that access to, of course, our staff, but also the local community to come and work on their own ideas. We have a shop floor where we produce the vehicles. It is a reconfigurable build floor, meaning that one day you can produce a motorcycle, and the next day you can produce a car, and the next day, why not a space shuttle? And then there is a sales component, a retail place inside the microfactory, so we design, build, and sell locally. This combination of co-creation on the one hand and micro-manufacturing on the other hand enable us to go 5 times faster than a typical OEM development, and reduce by a factor of 100 the cost to go from an idea to a vehicle on the road. Here are a couple of examples. This vehicle is called the Rally Fighter. It's a desert off-road racer. It is produced in our microfactory in Arizona. The microfactory is based there because it's in the middle of the Southwest, in the American Southwest, in the middle of the desert, because this vehicle is meant to be used there. The young designer that you see here on the top left is Songo Kim. He was a design student at the time he uploaded a site sketch of the Rally Fighter. And before he got graduated, he already had a vehicle from his design on the roads of the United States. We've produced about 130 of those, of this vehicle. It is street legal in the United States. And it took us 18 months to go from site sketch that Songo uploaded to the car on the road. Typical OEM development is 5, 6, sometimes 7 years. So from the very first vehicle, we managed to compress the timeline, compress the time between the idea and the vehicle. We then got approached by an agency called DARPA. DARPA is the Defense Advanced Research Project Agency. They are basically the innovation branch of the US Army. And they came to us saying, oh, we love what you did with the Rally Fighter. Could you do that for military relevant vehicles? And we said, sure, let's do that. So we hosted what we call a scoping session. We got people that had been deployed and were now working with DARPA back in the United States. We got them around the table and we defined an application for that vehicle. We came up with a reconnaissance and recovery mission. And fast forward 5 months, we went through different processes. We did an industrial design challenge, got 162 entries from all over the world, picked the one that was the most relevant, selected the different components, packaged that into a vehicle, engineered the vehicle, prototyped the vehicle, tested the vehicle, iterated on it, and delivered it ahead of schedule and on budget at an event where President Barack Obama was attending and talked about us in very kind words. All that in 5 months. A typical military vehicle development is closer to a decade-long project in the United States. So again, we showed that the process that we're using is far more efficient than what is currently out there. We did a couple of other vehicles, like the Racer. The designer of this one is from Portugal, Andre Costa. We did also a powered bicycle. This is the Cruiser. The designer is from Romania. His name is Ioannis Vasilaros. And we did a couple of projects with other third-party companies, a truck manufacturer called Peterbilt, the equivalent of a Volvo truck, BMW, Siemens. We also did the ultimate pizza delivery vehicle with Domino's Pizza, having a lot of fun doing that. We're also now working on technologies related to production. We talked about the design through co-creation, but there is also new technologies coming up, and we want to leverage those technologies that we call direct digital manufacturing. And so we ran an industrial design challenge in 2014, and we asked our community, what would a 3D printed car would look like? And this is the winning design out of over 200 entries in that challenge. The concept is called the strati. It means layers in Italian, because the designer, Michele Anoe, comes from Italy, and strati means layers. From this result, we then went ahead and we partnered with the Oak Ridge National Lab in the United States and a gantry manufacturer called Cincinnati. And we built a container-sized 3D printer, probably the size of this floor here. And we went to the International Manufacturing Technology Show and we 3D printed a car. So it took 44 hours to lay the 136 different layers. I'm sorry about the shaky image. We're going to skip it. There are some pictures afterwards. Sorry about that. The person that you see here on the top left is Michele Anoe, that we flew from Italy for him to sign his design on the floor of the IMTS show. We went from nothing on the table at the beginning of the show to a car rolling down the aisles. After printing the vehicle, took 44 hours. We took another 20 hours to refine some of the surfaces. So that's 44 hours. In 64 hours, we're now taking that process to less than 24 hours to 3D print a car. Not just the body parts, but the actual structural components of the vehicle, also including the hood, the trunk, the seats, the dashboard, all of that in one shot. Consistently reducing the number of parts of the vehicle, consistently reducing the complexity, and having full flexibility, meaning that there is no tooling cost. If we don't like the front fascia of the vehicle, we change the CAD file, press print, and we've got the next iteration. So what's next? Well, next is getting those vehicles highway certified in the United States. We're currently working on the next iterations of the vehicle, starting with a neighborhood electric vehicle, a low-speed electric vehicle. This is a winning design of a challenge we ran last summer in July 2015, and this is the vehicle 2 months later in September 2015. So again, showing that we are reducing the time to go from an idea, from a concept, to a vehicle on the road. Okay, looks like we've got a tight computer. Sorry about that. It's troubling because that was the best part now. Help, please. Okay. Can switch to my own computer if required. Do you have? Yeah, probably need HDMI. That's the joy of the presentation. So, as you've understood, we design, we build, and we sell vehicles. We're using digital age tools to do that, and we're now pushing the boundaries on how to reduce the cost to go from an ID to a vehicle on the road using direct digital manufacturing. Now, looking at the product that you've seen so far on the screen, those products are well designed for the American market. But we have a goal to expand our network to other areas of the world. We currently have a microfactory in Arizona. We're building one in Knoxville, Tennessee. Another one in Washington, D.C., a place called National Harbor. We've got a lab in Las Vegas, and we're building a lab here in Berlin. I say here in Europe. Our goal is to expand this network, and looking at the European market, we felt like we may not have the right set of products. And so we challenged the community to come up with new concepts around the field of urban mobility. We ran a conceptual design challenge and took Berlin as the test bed to showcase the creativity of the community. We had a number of interesting concepts, one of which is a dynamic driverless vehicle system. And I'm going to do that just with my hands, so please bear with me and don't stop watching this one. The system has 4 different elements. The first element is an app. So if I'm going from here to the airport, I'm going to ask for a ride. The vehicle is going to come and pick me up in front of the doorstep. There you go. Okay. This is the map of the microfactories and the way. Thank you so much, and the fact that we want to then expand this network. 70% of the world population by 2050 will live in an urban environment, putting pressure on the infrastructure, and this is what you want to avoid. You know, building more lanes for motorways and getting to those gigantic traffic jams, gridlocks. This is traffic jam that happened at the end of 2015 in China. After a one-day holiday, then people came back home, but then they got stuck into a traffic jam that lasted 10 days. The average speed on some of the sections were 1 kilometer per day. Okay? So basically what we learn is that the car is not the answer. You need to find new solutions. So we went ahead, we did the Urban Mobility Challenge. You follow me now? Okay. Going back on track. What we learned is that the future is sustainable. It's going to be lightweight, it's going to be electric, it's going to be recyclable, upgradable. The future is going to be shared, because today our cars are standing still 95% of the time. We're seeing emerging business models addressing that very thing. We've got Drive Now outside. This is about leveraging the asset and sharing it with others. And the future is going to be shared in that way. The future also is going to be driverless, because we are very poor operators of our vehicles. We're getting into accidents. We're injuring 50 million people every year in road traffic accidents. We're killing 1,250,000 people every year in road traffic accidents. 80% of the time, this is the driver that is the faulty actor. 1,250,000 people dying every year. This is the equivalent of an A320. You know, those Airbus 320 planes from EasyJet or Ryanair, or those low-cost airlines, crashing, killing the 150 people inside the vehicle, inside the plane, every hour, 6 minutes. This is incredible. This is so dangerous, and we're just so close to it that we cannot figure this out still. Now the technology is here to reduce those deaths on the streets. And by the way, there's going to be able to provide us with enhanced experience. We won't have to operate the vehicle to go from point A to point B. The vehicle is going to drive us. So this is why I believe that we're entering a mobility revolution. Because when you have sustainable, shared, autonomous vehicle, then you can completely redefine how people get around, how you design the streets, how you design the towns around this revolution. So that's why we're introducing the Edgar system, dynamic driverless vehicle system, composed of 4 different elements. The first one that I had started to talk about, the app. So I'm going to the airport, I order the ride, the vehicle stops in front of my doorsteps, I get into the vehicle, and it either get me to my destination, or it will drop me at the closest train station that go directly to the airport. It is interconnected. It is multimodal enabled. And within the app, you can do the registration, ticketing, and billing. Second element, oh no, come on. Let's see. Second element is the vehicle. Yes, it has 4 wheels. It's named Edgar 08. Edgar for the name of the designer, Edgar Sarmiento. He comes from Bogota in Colombia. 08 for the number of people that can get around in that vehicle. Or actually, we're learning that we're going to be able to put a little bit more. It's going to be 12. The vehicle is upgradable from a software perspective, but also from a hardware perspective. It is built-in capability of plug and play for taking out the old generation sensor and putting the next generation sensor. Same thing for the computers, the batteries, and the motors. The vehicle is beautiful, it's sustainable, it's smart and accessible, and it reroutes itself according to real-time traffic data. If there is a traffic jam, if there's a car crash between here and the destination, it will take an alternative route autonomously. It is also reacting to real-time demand and optimizing its routing to get people around. It is also plugged into the historical data and optimizing the dispatch of the vehicle in the area of operation. So we know that Damien, every Monday morning at 7:30 a.m., he leaves home to go to work. Then a couple of seconds before, the vehicle can be pre-populated in front of the doorstep. On the back end, we've got everything that is required to manage the fleet, making sure that the vehicles are maintained, they are fully charged before reaching peak hours, and are connected to the rest of the public transport network. We provide the services, the operations for everything to provide a turnkey solution. And we're basically enabling new business models for public transport operators by significantly reducing the cost of operation, and enabling new fleet operators to get into the field of mobility as a service. We've got some very interesting impact scenarios where we can extend the public transport network. Today, you've got bus lines that stop at a certain point because after that, it's non-economical to have an extension to the bus line. With autonomous vehicles, then you can use the vehicles to come and feed this node. You also can densify the public transport network. I don't know for Copenhagen, but in Berlin, wherever you are in the city, the closest bus stop is about 300 to 400 meters away. When you have good legs, that's all good. When it's pouring rain or when you're an old person, then 300 meters, you're disconnected. Here with autonomous vehicles, we can come and get you in front of your doorstep and bring you to the public transport network. Last impact scenario, of course, is the substitution of the human-operated fixed-lane bus lines, but also the human-operated cars. Got great partners, and here are a couple of renderings of the vehicle. What you saw so far was renderings of the concept. Those are renderings from the CAD files. And here are the team currently building it as we speak. We're building 2 vehicles. One will be operated in the US, the other one will come here. This is the team putting into the vehicle the battery. And guys having fun, just fitting different components on the vehicle. We're introducing this new system and we're really excited about it because this is just a starting point. With this vehicle, we can address a number of use cases. But then this is just the first vehicle. Where we are now is we're introducing this vehicle at the end of this month. We're going to then go into industrialization, selecting where there is the largest demand for the vehicle, opening up a micro factory to build those vehicles, and then go to production in 2018. Meaning being in full production in 2018. We already have an order for 4 that will deliver in 4 months, 5 months from now. This is the first vehicle, fairly utilitarian, fairly bulk transport for up to 12 people. But then we can go even further, having a vehicle for 30 people, 40 people, or on the other way around, having a vehicle that is much more for smaller purpose, 2 people. This would be the equivalent of a car-to-go, for example, but without a driver. You don't have to walk to the vehicle comes to you. You don't have to operate the vehicle. You can do whatever you want between your point A and point B. And once you're at your destination, you don't have to park the vehicle. The vehicle goes to take its next ride or parks itself. And then we can provide more exclusive experiences, providing an interior with leather, with nice wooden accents, with a cappuccino machine, and provide a more of an Uber Black type of experience. And so therefore, we've got our playground here, or we can put dots on that map and define if there is an interesting segment to address. This is for the transport of people, but you can also look at the transport of goods. And here is the Edgar 08, but for a cargo application. So here you can leverage the vehicle, but to do another application, having a UPS or a DHL leveraging that vehicle to deliver parcels. Next step into the sharing economy is to share the asset between different applications. We could imagine having an Edgar 08 being leveraged during peak hours for transporting people, and off-peak hours being converted to a cargo application. Having a national public transport operator share the vehicle with a postal service. There you go. Thank you very much for your attention.
There is time for 1 or 2 questions, so if you have a question or 2.
Sorry about the technical issue.
We have a question over here. I can hardly see you. Can you repeat?
The cost of the last vehicle? Yes. So today we are still on prototyping phase and pre-production batches. We have high costs because we've invested a lot. The first one that we've sold were in the region of 200,000 euros. And we're working on taking that cost down. The cost of batteries is going to go down. The cost of the sensors are going to go down. Today, your LiDAR is still very expensive. And the target cost or target market price, let's say, for this vehicle within a 3 to 5 year time frame will be around 80,000 euros, from the 200,000 to 80,000. Thing is that it's not just about the cost of the vehicle. It is the services that it can provide. Today, if you look at a 12-people bus and you operate a bus to get people around, half of the operational costs are linked to the driver. Take out the driver, you can have more service. You can reach more population with the same amount of funds.
What makes you believe that you will beat BMW, Mercedes, Scania in this plane?
We're taking a different approach. Basically, we have, on the one hand, the OEMs that are taking the incremental approach of providing advanced driver assistance functionalities and building on that. And we're taking a different approach. We're going directly to level 5 autonomy and building it from segregated area to non-segregated area. So that's 2 different approaches. We'll see who would be the right one to get there.
Thank you. Thank you very much, Damien.
Thank you.
Thanks you could come here.